So today, in the chapter of transfer of thermal energy, we are going to start with the concept of convection, right? So first of all, the last process we discussed that is especially related to the conductors, right? Because mostly we observe that phenomena in solids. And today we are going to discuss about convection process, and this convection process involves the liquid molecules and the gas molecules. This process is not for the solid one, and we will discuss in the topic that why this process not helps the solid molecules to transfer thermal energy. So the name of the process is the convection process. Basically, the name convection derived, or basically it is the abbreviation or it is the drive concept from two different words. The first one, CON, it is taken from the word conduction, and the rest of the part of the convection, that is vection, is taken from advection. So basically convection derived from these two words, and we already discussed about the conduction process, that in conduction process it involves the collision between the atoms of the or the molecules, right? So last time we discussed about conduction. And if we talk about the advection process, so what is the meaning of advection? So conduction means collision between molecules, or you can say that the collision between the atoms. And if we talk about advection, so it explains the concept of bulk motion of molecules. So today we are going to discuss about the process which involves the bulk motion of the molecules, and that motion can be started by the collision between the molecules. So initial process remains the same, but today we are going to discuss about the process which involves bulk motion of the molecules. And liquid and gas molecules are free to move as compared to solid. So that's why bulk motion means that multiple number of molecules are going to move at a same time. In solids, you know that it actually transfers from one point to another. Like if one molecule gets energy, because solid molecules are tightly packed, so they are not able to move just like liquid and gases, right? Just like if you take the example of the liquid, when you start boiling the liquid, so all the molecules are going to move at a single time. So it will not happen like in a solid, because when you supply thermal energy to the solid, so solid will not expand, or you will not observe a very quick change just like the liquid and gases. So bulk motion means when like 100 or 1,000 number of molecules if we consider, so they starts to move, or they starts to change their position or transfer energy at a same time, right? So basically in convection we can say that molecules gain heat energy and travel from hot end to the cold end. Basically, this is the difference. In solid, we used to write they starts to vibrate. But for liquid and gases, we used to write that they starts to travel from hot end to the cold end, and collides with one another along the way. So this is the concept of convection. That in convection, molecules gain same heat energy just like in the conduction, but now multiple molecules are able to move at a same time. That's why we use the concept of bulk motion of molecules. And you know that when they starts to move, so definitely they will collide with each other and they transfer energy from hot end to the cold end. So this is the process of convection. And in start, we already discussed that convection only take place in liquid and gases, right?
Convection takes place in liquid and gases only?
Yes. So basically convection process takes place only in liquid and gas, right? Because you know solid molecules are tightly packed with each other, so they cannot change their position just like liquid and gas, right? Any confusion?
No, sir.
Because they are not able to move, they are only able to vibrate. So that is the difference. So that's why convection only takes place in liquid and gases. Any confusion till now?
No, sir.
Okay. So because you know about the idea that we discuss about solids, so same goes with the liquid and gases, but with a little bit difference of the property. They will move slightly different from the conduction process and from the solid molecules. And further, in exam, if they ask about that what is convection current or state or explain convection current, so that is also a concept of convection current. Let's see how to explain that concept. So the question is, what is convection current, right? So basically, you know the word convection, you know the process of convection, and the word of current means that we have to identify the direction, or you need to explain with the reference of specific direction, right? So normally, if you consider the diagram, so in diagram, you can see that we are just providing thermal energy from the bottom of that container. And then you can see that arrow is going in upward direction, and then it revolves around the whole container, right? So the thermal energy is supplying to overall the molecules in the of the liquid, right, in the container. So basically the hot side of the container is the lower end and the cold side of the container is the upper end, right?
Yes, sir.
So if you want to write about what is convection current, right? So basically we can just take the reference from the diagram and you can simply write the first point. You may consider the example of gas or the liquid, it's up to you, because normally we observe the concept of the liquid molecules. So that is the easy one. So we take the reference from liquid diagram or the liquid process. So that happens same with the gas molecules. So we can say that liquid at the bottom gains heat. Second point is liquid starts to expand. And what will happen next? The density of the liquid will decrease, right? Because these are key points that will help you to write your answer for like 3 or 4 marks if they ask in your exam. Use fluid as it includes liquid. Yes, you may also use the word fluid on the place of liquid and gases, because liquid and gas both are able to flow. So you may use that word fluids. It's up to you. And when the density of the liquid decreases, so what will happen next? It starts to move in upward direction, right? Or you can say that it will rise. And the one more point is, because you can see in the diagram, that arrow shows that it is also moving downward. So basically the molecules which are getting high energy and that becomes less dense, so they starts to move in upward direction. And the dense molecules, like the upper part of the liquid, that those molecules are the dense ones, so they starts to move in downward direction, because the density of the low energy molecules is high as compared to the high energy molecules, right? So you can say that the cooler moves because you know that the molecules with low energy or with low temperature as compared to the hot side, so they will become dense, right? And they will starts to move in downward direction, or you can say that those liquid molecules starts to sink. So basically the diagram in the convection current or the diagram in the liquid shows you the same process, right? The high energy molecules starts to move in upward direction, and the low energy molecules it starts to move in downward direction because of high density, right? Clear? Any confusion?
No, sir.
No, sir.
So this is the process, or this is the concept of convection current, right? Or you can say that the convection current in liquid or gases. And if they ask why convection process does not take place in the solid, so you know that solid molecules are not able to move. They can only vibrate about their fixed position.
Sir, the convection process, is it faster in liquids or gases?
It is faster in gases because they are far away from each other. We will also discuss the concept of air, because there are multiple examples included in the convection process. We will also discuss the process in gases also. because there are many practical life examples related to the convection in air, right? So we started from the liquid because we observe liquid very like the normal situation in our daily life. So that's why we can easily understand the process of convection with the reference of liquid. So then you are able to apply that same concept on the gases, right?
Okay.
So basically, if they ask why not in solids, so you know the concept that solids are not able to move, they can only vibrate. So solid molecules are not able to move, only vibration will be possible for the solid molecules. And we discuss 5 important points related to the convection current. So if they ask in exam for maximum 5 marks, so they will not ask like a very detailed like this for 5 marks. Mostly they ask about like 3 marks, because in old papers mostly you somewhere you find the question that is like 4 or 5 marks. So that's why I just write different 5 points, so that will help you to understand that we use these points in our paragraph to write the complete answer for the process of convection current, right? So this is the concept of the convection. And further, if we discuss some examples, just like further in solids, sorry, further if we talk about in liquids, so you know that when you start heating at the bottom, right? So in the first process, you can see we are just providing thermal energy at the bottom of the container. And if you supply energy or thermal energy from any side of the container, so these two process explains you the concept of convection. But if you consider the third diagram, so basically in third diagram, what is the difference? That we are just using electrical heater from the upward direction. So this time we are providing the thermal energy from the upper side, like we are providing heat at the top. So when you are providing heating at the top, so that is not an example of convection process, right? And what is the reason that if you are using heater on the top side of the liquid, so why that not give you the idea of the convection current? So answer is very simple, because you know less dense molecules, either it is of gases or liquid, they start to move in upward direction. So if you are providing thermal energy from the upward direction, so they will not follow the convection direction, just like we discussed, or they will not follow the concept of convection current, because in convection current high energy molecules starts to move in upward direction, but you are already providing thermal energy from the upper side, so convection current will not follow their normal path. So that's why in first two diagram convection current process is possible, but in the third diagram convection current process is not possible, right? Because thermal energy source is already at the top. Okay, clear?
Yes.
So basically in the third diagram, heat source is already at the top, So dense molecules will not sink. And does not produce convection current. Okay, what about the cooling process? Basically, we are talking about only the thermal energy, but if you are providing or if you just decrease the thermal energy, right? So that will also make the change in thermal energy, right? Because that will also give you the difference of temperature, right? If you start cooling the liquid. So basically, there are again two diagrams, and now you can easily identify the difference that in first diagram, we are providing or we are going to cool the liquid from the bottom side. But in second diagram, we are trying to cool the liquid from the top side of the liquid, right? So you know that when you are just cooling the liquid, so basically you are going to increase the density, right? And when the density of the molecule increases, so they starts to move in downward direction. But in first diagram, the cooling source is already at the bottom side, right? So again, the direction of the convection current will not follow because dense molecule or the dense source or the cooling source of the liquid is already at the bottom, right? So they will not follow the direction of convection current. Okay. Any confusion?
No, sir.
So you can explain the concept like this: cooling at the bottom, because there are multiple scenarios you will find in your past papers, like these different experiments. So sometimes we got confused that we only studied about the thermal source, but what happen if we use the cooling source over there, because that will also make the difference in the temperature between the bodies. So that will also makes the flow in convection current, right? So when you are cooling at the bottom, so cooling at the bottom does not produce convection current.
Sir, when the heater is placed on the top, so convection does not happen. So how does the thermal energy transfer? Is it conduction or something?
Basically, that is known as the convection, because that is transferring energy and molecules are moving, but that is not the example of convection current, right? Because first we discuss the concept of convection current, that what is convection current. Convection is simple a process, and that process involves when you provide thermal energy, or thermal energy is provided to the molecules, and molecules will starts to move in bulk quantity, right? It means different number of molecules starts to move at the same time. Okay. But if you talk about the convection current, so convection current means a specific direction. So we have to follow a specific direction, right? So
So
convection,
convection is
yeah,
happening, right?
yes, but there will be no convection current, right? That's why I write no convection current. Okay.
Thank you.
Because you know convection happens only in liquid and gases, so definitely it is a convection process, but if you follow the proper direction, so you will not get the direction of convection current.
Okay, thank you.
So basically cooling at the bottom does not produce convection current, as uh, water at the bottom will. will be more dense and heavier. So it will stay at the bottom. So that's why convection current will not happen, right? And if you just take the opposite situation in figure number 2, so you are able to understand the convection process automatically because arrows are already given over there, and you can compare from the first diagram that how convection current happens in the second diagram. Okay. Any confusion in convection current?
No, sir.
No.
No.
So basically, these are the concept for convection in liquid, but if we want to apply the same concept on the gases, because now you have enough concept, enough knowledge about the convection current and the convection process. So if we talk about the convection in gases,